inconsistency means maybe we can face inconsistency, right? Because of different branch data you are using, right? Inconsistency means, let's say the same data, once you use different styles or patterns to store the data, because of that, it will consider two different values, right? The same record, you note it down in different way. Just think about, right? Uh, the previous example I told you, right? Let's say one hospital, right? They record the patient's glucose level, mole per liter, right? Mole per liter. Oh, just simple thing, right? Just imagine, right? Okay. One telecommunication service provider, right? They will record the data consumption, right? Data consumptions of their customers, right? One branch, they will record the data consumption in megabytes, right? Megabytes. Another company or another branch, they will uh, record the data consumption in gigabytes, right? So let's say if you think about if you are using these two units, because these two units are different, right? So if someone consume, let's say if you think about someone consume, right, 100,000 megabytes, right? Another guy consume, right, 100 gigabytes, GBs. Okay. Oh, okay. Just think about 150 GBs, right? Now tell me which one is the largest one, largest value.
150, sir.
150 is the largest value, right? So as a human, you know, right? You know the scaling, how to convert the MB to GBs and other things, you know, right? As a human being, we have 6 tenths. We are using that 6 tenths. We can divide it by 1024 MBs to convert into GB. Then you are comparing these two, right? That is the human nature, right? So that is not happen while you are dealing with machines, right? So if you are dealing with the machine or whatever we are doing with data analytical work, right? The algorithms, they will train, they will learn whatever the input values we are putting to that one, right? They don't know these MB data, they will done by the machines, right? But if you feed this 100,000 and 150, they will think as a machine, it will consider this one is the largest value. The number is, they know only the value of the numbers, right? So because of that, your model learned incorrectly, right? To sort it out, this problem we are using correct the inconsistency. Inconsistency means if you are using two different units, or maybe you are using two different structures to store the data, right? Because of that, your model misunderstand the things, right? While the model learns something from your data, if you are feeding to the model algorithm, they will learn incorrect way. To overcome this challenge, we are using the inconsistency corrections. We will correct the inconsistency in your data. Inconsistency means you will check, right? Let's say sometimes we have, let's say if you think about the bank, we have different branches, right? So you need to check whether all the branches are using the same formatting or same unit to store the data, right? So before you integrate, you need to check. Let's say in branch A, they are using this format, right? In branch B, they are using this format. So better way, you can use one unique format while you are integrate the data from different branches. Then you are sorted out the problem. Similarly, one company, let's say you are doing a research for telecommunication service providers in Sri Lanka, right? One service provider, maybe Dialog or Mobitel or Hutch, they are using megabytes as a unit. Another service provider, they are using gigabytes as a unit, right? So once you collect the data from different service providers, right, what will happen? Definitely you need to correct the inconsistency. It means maybe you can convert this uh, data records into GB, or maybe you need to convert this data into MB, right? That is we can call remove the correct the inconsistency. If you have an inconsistency in your data, then you can sort it out, or you can convert, or you can apply some techniques, and you can sort out the inconsistency in your data. Then only your model uh, perform well, right? It means if you, let's say, if you think about a baby, right, they will learn from the surroundings, right? So in the early stage, we uh, they observe the things, right? They, as a child, they observe the environment and surrounding. From that, they will learn, right? Or maybe whatever the things you are telling or you are teaching for them, they will capture those things, and they will react in the future, right? That is the thing happens. Similarly, in machine learning also, or data analytical things, if you are train a model, in the sense, whatever the data you are feeding to your algorithms or your model, depending on the data you are enter into the algorithm, it will learn. Depending, maybe if you are give a different data, they will learn from that data, right? If you may, even if you input a wrong data, incorrect data, it will learn for that incorrect data and react based on that way, right? So to overcome that challenge, we are remove the inconsistency in your data. Did you get my point? The person who asked this question. There is
Yes, sir.
nothing you can convert the same units, or you can use the same structures of all the data records, right? Any questions? Any questions? Any questions? Okay, if you don't have any questions, right? So we will move for the data integration. Right now, you are clear with the data cleaning, right? That is a major part, right? Data cleaning, right? So now we are move for the second topic, data integration, right? So depending on the title, you can understand, right? What is data integration? Tell me why we need to integrate the data. What do you mean by integration? Integrate kya? Sorry. What do you mean by integrate?
By the data, sir.
Sorry, combine the data. Yeah. So why you need to combine? Tell me.
There are different types of data here. So as per our requirements, we want to combine those different data.
Yeah, very good. So if you think about whatever some companies, right, they have branches all over the world, right? Maybe some companies, if you look at, they have branches in different places, right? So if they are dealing with a centralized database, you don't need to worry about anything, right? Centralized database means, I think you know, right? There is a one database. They will deal with all the transaction with that database, even if you have n number of branches, right? But they are using only one database, centralized database. So whatever, let's say you have 10 branches in the country, right? 10 branches in the country, right? So all the branches access only one database. Is it a good practice or bad practice? Tell me.
That's
Why?
we say if any error in occurred in that database, so all the information will be lost.
Yeah, very good. What else? What else?
Time
Tell
consuming,
me.
sir.
Hmm?
Time consuming is high,
Mm,
sir.
in which way? For which
Same time,
purpose you have more time?
many of the users can ask one information. So the requirement resource sharing is maybe delay.
Yeah, very good. Yeah. Yeah. What about others? Did you get the point he telling?
Yes.
If you have a centralized database, what will happen if you have a failure or down the database because of some errors? the entire 10 branches down, right? That's the thing happen. I just imagine you are running a big company, right? You have 10 branches in 10 different places in the country, right? So if your date, maybe some issues, or maybe normally what will happen, sometimes you can assign some trainees for some database upgrade or some works. They have some mistakes. Definitely, they did some mistakes. Because of that mistakes, your entire database is corrupted, or maybe your entire database is locked or something. Something happened, right? So at that situation, what will happen? Your 10 branches down, right? So it is not a good practice. You are dealing with a centralized database, right? For that purposes, normally the industry, they will design something called let's say normally while you are developing some post systems, right, point of sale post systems or some other uh, business application, right, normally we design an architecture, right? So the normally, let's say if you have a 10 branches, right, you have 10 separate databases, right? That's the thing you happen, right? Normally what will happen, you have separately developed 10 databases, right? Let's say you have 10 databases for 10 branches, but you did something called, right? You have a one centralized database, right? Or maybe you have a one repository to manage all the data transactions, right? Every day, right? Let's say every day, midnight 12, right? All the transaction from your all the branches uploaded to your main repository. That is a normal structure. You are developing some application, right? Maybe you are develop some mini projects, or for any projects, maybe you can apply those techniques, right? Maybe you are someone interesting to develop some point of sale systems, right? As a business requirements, maybe you can develop some post systems, right? More advanced features with user friendly. Then at that time you can apply this one, right? So normal thing, for let's say you have a 10 branch, for each branch you develop separate database, right? Then all the transaction in a particular day, it will upload to your main repository by 12 midnight, right? So midnight 12, all the transaction from all the branches uploaded to the your backup database or your main repository, right? That's a normal thing, right? So data integration means normally if you are dealing with the data analytical or data scientist related things, data analytical things, definitely you are dealing with more number of data, right? So we cannot consume all the data from one branches, right? Or maybe sometimes we need to get the data from different uh, sources, data sources, right? So just think about maybe you are planning to develop research, rainfall related things, right? You are doing a research, rainfall data, right? So if you look at the rainfall data all over the country, we have different stations, right? Maybe base stations. They are they continuously monitor. Then also they are measure the rainfall in different places, right? Then they will upload to their databases, right? So at the time, what will happen? You need to merge more number of branch data into a single Excel sheet or single file, right? So data integration means you are merging different source of data for a particular purposes, right? From different branches or different stores, right? So at that time, what will happen if you are merging the data from different branches, right? We don't know whether all the branches are using the same style, right? So that is we are discussed previously, data inconsistency. You need to correct the inconsistency in your data, right? Maybe sometimes some branches maintain, let's say some branches, they maintain the accuracy for two decimal values, 25.89, right? Two decimal value accuracy. Some branches, they will maintain 25.295, three decimal point accuracy, right? Even that one also impact the outcomes, right? So similarly, there are so many things you need to check in your in data, before you integrate the data, you need to check the inconsistency in your data, right? Maybe inconsistency with the help of units, measurements, right? Maybe, or how many, what is the accuracy values, how many decimal points they are considered. There are so many things you need to consider in the inconsistency. So if you integrate the data in a proper way, you can avoid so many uh, errors or so many issues happen in your data, right? So now tell me how, let's say, think about in the previous example, you have different databases, right? So different internet service, different telecommunication service provider have different databases, right? Now, how you can check or how you can check the inconsistency of their databases? Tell me. Maybe you can check with the database schema, right? What do you mean by database schema? What do you mean by database schema? Hmm? I think you know. What do you mean by database schema? I think you learn in your first year, right? In the advanced DBMS or database subjects, you can learn. What do you mean by schema? Database schema? Tell me. It's a very basic question, right? That's why I always told you, right? Whatever the things you are learn, don't forget those things, right? You definitely need those things for your entire journey, right? Not only for academic journey, not only for your university journey, even if you move for the industry, definitely you need to aware those things, right? Yeah, just simple thing, right? Yeah, it's correct. Yeah, schema in the sense that is a metadata, right? So all the things about the database you are defined in the database schema, right? What is the type of the data? What is the length, right? All the metadata, data about data, we can call metadata. So for the database, if you have a schema in the sense, you can define all the aspects of your database in the schema, right? Maybe you can check the database schema to check the inconsistency in your data, right? So in the schema, they will define what type of data, what is the maximum length of the input values, right? There are so many things we can define in the schema, right? So once you check the schema for different branches, you can easily note down the problem, or you can find out the data inconsistency without spending more time, right? So otherwise, what you need to do, you can check with the data records, and you need to do so many analytical things. You need to go through your data to find out. But if you check that database schema without any issues, you can very easily find out the inconsistency in your data, right? So they are telling the examples, right, for the data inconsistency, right? So maybe it's one branch, they will call as a customer ID as a one column. Then they will uniquely record the customers, right? Another branch, maybe they are using different names, right? Customer number or something. They are giving different column names, right? So the whatever the thing happen, right? If you merge the data, sorry, the integration means you are merging the data, right? Just think about, this is a table one from one branch one. This is a table two from branch two, right? So here we have some couple of fields. Here we have some couple of fields, right? So maybe this branch they are using C number, customer number as a customer. Another branch they are using customer ID, but both are same, right? But if you integrate the data, if you use, this is a separate column, this is a separate column, this is a useless thing, right? Normally both are same thing you are indicating, but if you don't aware about the title or column names, you can consider separately these two columns, right? Likewise, there are so many things happen, right? So while you are integrate the data, right? Sometimes, let's say, if you think about the bank tables, right? One branch they are using their account type, right? Their account type as a serving account, servings and current account, right? Another branch they are using first name S and C, right? So that is normally happen, right? So what will happen? One this branch they are using the full name, right? For the customer serving, serving current account. Likewise, they will record, right? This branch they are dealing with S. Likewise, it will go, right? So if you directly integrate these two tables and if you train the model, what will happen? Tell me what is the actual problem. Without considering data integration, if you do these things, what will happen? What is your thing? What do you think? So this is a full name, servings, current. Here S and C is only there, right? Now, without doing anything, without doing any data inconsistency and other things, if you directly integrate these two tables, what will happen? What is the problem you are facing? Tell me. What will happen if you are directly integrate these two tables? Hmm? Tell me. The normal thing, by integrating these two tables, you are creating a large table, right? With, let's say here, 500 records. Here we have 500 records. Altogether, we have integrate these two tables and we are creating a yeah, main table with 1,000 records, right? So now tell me what will happen, right? If you are using here the full names, here you are using the first letter. If you integrate these two tables, what will happen? If you get my questions, answer me. So data integration means you are collecting the data from different branches, right? Then you are creating a one base file or one main file. It contains all the data records from different branches, right? Now I am explaining a situation, right? Here, maybe their ID, right? This is account type. Then this is a balance, bank balance, right? Here also, this is ID, this is account type, this is balance, right? Now, tell me, if you integrate these two tables, definitely you are getting a table with 1,000 records, right? Now think about this one and this one. Tell me what will happen. Now, what will happen here? Here, serving, savings, current, maybe current, serving, right here SSSCCSSC, likewise it will goes, right? Now tell me about this attribute. Hmm? Tell me about this attribute if you integrate this way and if you develop a machine learning model. Tell me. Very simple thing I am asking, right? You have two branch databases,
Maybe a
each branch with,
misconception here, sir.
sorry, tell me again.
There
Can
may
you
be a
repeat?
misconception in following the model. Misconception.
Yeah, that will happen, right? I'm asking you what is that misconceptualization?
In order to identify the values, some it may be the string, and after it will only see the char value. So it will be the errors in the systems.
No, maybe you're a bit close to the answer, right? So if you feed these 1,000 records to train a model, what will happen? Something happen that is a totally wrong concepts, right? That's why we discussed in the previous classes, data types. Just think about the way data types, nominal, numeric, ordinal, binary. So just link those things with this one. Anyone? If you know the answer, tell me, right? Sometimes your answer may be wrong or right. It's okay, no worries, right? Just we are coming for understand something, right? We are planning to come here. Maybe some of you are not taking the subject just to get the knowledge you are coming here, right? So I'm asking you, right? Just a practical scenario. You have collecting a data from two branches. One branch, they are maintaining account type as a full name, right? Serving the entire string, they will write as a account type. Another branch, they are using first name of the letter, right? S means serving, C means current account, right? So once you merge these two branch data into a new table, so I'm explaining, this is the table, right? So if you look at this table, tell me what is the issue in this table. If you use this table for training purposes or model training for or data analytical work, if you are using this table, what will happen? There is a misconceptualization happen for your algorithm. What is that? Tell me, what is that misconceptualization? What is the misconception in these 1,000 records if you are using this way? That's why I told you, you need to remove the inconsistency. Don't you get the answer? Anyone? Just think about with data types. Yeah, very good.
So you're asking, they might think both datas are different.
Yeah, yeah, very good. I think 069. Yeah, your answer is correct, right? What about others? That is a big mistake, right? If you do this way. That's why I told you earlier, we as a human, we can understand, right? But not the case in the machines, right? They know only zeros and ones, right? Whatever that we are passing to them, they will learn from that one, right? That is machine learning, right? We cannot expect the same way how human learn, right? What about others? At least if you find out the answer. Maybe, yeah. There is a simple thing, right? Just think about these values for that account type. Okay, I will tell you the answer, right? So normally, right, the account type is a binary attribute, right? Did you get my point? But once you integrate these two tables, it considers a nominal, right? Why? Binary means only two possible values, savings or current account. These are the two types of account the bank currently provides service, right? Current account and saving account, right? But if you look at this table, what will happen? Just look at here. This is one unique value. 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 That is the way your machine understand, right? If you integrate without applying the data inconsistency, machine understand for account type, they have four different types of account. What are they? Saving account, current account, C is another type, S is another type, because machine, they don't know anything about the meaning or your understanding about the data. Whatever the things we are feeding to your model or feeding to your algorithm, based on that data, they will learn some knowledge, right? Actually, you have a binary data type for account type is a binary attribute, right? But if you integrate without converting or without applying data inconsistency, without correcting the inconsistency, if you apply, machine understand, okay, for this account type, we have four different types of account, right? That is a fully wrong concept, right? So what you need to do, maybe you can convert all the uh, single character type into the full name. Maybe you can convert this is also a serving current, the full name way, or maybe you can convert all into first letter format, right? So maybe this table you can convert into a single character form, SS, CC, S likewise, or maybe you can convert this one into the full format, right? So once you apply this data, once you apply the correction of data inconsistency, then if you integrate the data, then what will happen? If you change this, if you apply the data inconsistency correction, then what will happen? This attribute consider only two types, maybe C, current account, C and S, maybe C and S, or current and serving, right? So it will convert into only two unique values, right? That's a big mistake, right? Don't do that. Just think about those ways if you are dealing with your final year research, right? You're not considering those things, right? Just directly, normally what will happen, you're collecting the data, just you can merge, right? Just copy, just create a column names, right? Just copy the data from all the branches data and just copy paste into your main database file, right? Main data source file, right? But these type of problems also occurred, right? So just think about these ways, right? While you are integrate, definitely you need to give more time to understand what will happen internally, right? Otherwise, you are not getting whatever the expected outcomes throughout your research, right? Okay. While you integrate the data, right, there are two types of integrations, right? Data integration, attribute redundance, right? Or tuple redundance. We can divide the data integration into two types, right? Attribute redundance and tuple redundance. What do you mean by attribute redundance? Tell me. Yeah, very good. 056, yeah, you're correct. Storing the data in multiple places. Redundancy, right? Okay, tell me, I think you learned normalization, right? Am I correct? 1NF, 2NF, I think you learned, right? Those things. So what is the purpose of normalization? Tell me. So why we are applying normalization techniques? Anyone? Answer my question. I think you learned those things maybe 1 or 2 years ago, right? But if while you are moving for an industry, definitely you need to know the basics of database, right? The query languages, DDL, uh, data manipulation language. There are so many basic questions they will ask, right? One type of questions, the normalization, right? Definitely have some questions, joins in the interviews, right? So why we apply normalization?
To reduce the redundancy of the data.
Yeah, very
on
good.
sc-
Duplicate values, removal, right? There are so many things we are dealing with redundance. Yeah, with the help of normalization, right? Oh, yeah, so many answers are there. So we are remove the duplicate values, right? So the purpose of normalization, we can remove the duplicate values and redundant values, right? So for that purpose, we are using 1NF, 2NF, 3NF. There are some procedures to check whether it's a 1NF, then you can check with the partial dependencies, and likewise it will goes to NF, 3NF, right? The 1NF means remove the duplicate values, right? So maybe you have comma separated values. Let's say, I think a simple example, right? Take some time, right? If I explain the normalization, right? Just you can revise the normalization things, right? So while you are integrate the data, right? Previously, we will discuss you need to remove the inconsistency in your data, right? Similarly, you need to check for the redundancy, right? If you have a redundancy in your data, right, before you integrate the tables, before you integrate the data sources from different data sources, you need to check for the redundancy, data redundancy. Is there any redundancies in your data, right? For that purposes, we have two types of redundancies, right? So first you need to check the inconsistency in your data. If you have inconsistency in your data, you can correct the inconsistency first. Then you can check for the redundancy in your data, right? If you have a redundancy in your data, you need to sort out the redundancies, right? So in here, we have two types of redundancies, right? Attribute redundancy and tuple redundancies, right? So attribute means this one, right? This is attributes, right? This one we can call tuples, right? Each record we can say as a tuple, right? So here we need to check for two types of redundancies, right? So tuple redundancy you already know, right? So in your data records, you can check is there any duplicate values, redundancies values, right? So to remove these tuple redundancy, normally you know the normalization techniques, right? So we can apply the normalization techniques to sort it out all the tuple redundancies, right? So maybe two or more identical tuples give the unique data, right? Then we can remove the, by applying the normalization techniques, we can remove the tuple redundancy, right? I don't know whether you learn this attribute redundancy in your database. I think so, not right. Am I correct? You are not learn about attribute redundancy in your database subjects, right? Only you learn normalization, right? That is a tuple redundancy removal techniques, right? Anyone know what is attribute redundancy?
Awesome.
Anyone have any experience? No, right? Yeah, okay, then I will explain. So attribute redundancy means, let's say, if you have a if you have a database table, right, they have n number of attributes, right? Let's say if you have a telecommunication database, they have n attributes, right? So we cannot use all the n attributes for the machine learning or model training purposes, right? For that purposes, we have something called correlation analysis, right? Correlation analysis among these attributes, right? I think we will discuss those things in your practicals, right? If if not, just search about correlation analysis, right? Correlation analysis, right? For correlation analysis, we are find out some heat maps or something, right? It means correlation means we will compare the attribute relations, right? Let's say if you have a 50 attributes, and you will check the relationship between the attribute, how the attributes are related to each others, right? That's correlation analysis, right? So attribute redundancy means sometimes what will happen in your attributes, right? One attribute, let's say you have one attribute A, right? You have another attribute B, right? You have another attribute C, right? You have a attribute A, attribute B, attribute C, right? Let's say attribute A is your maybe your weight, right? Body weight. Attribute A is a weight. Attribute B is your height, right? Attribute C maybe we can say BMI, right? Body mass index, BMI, right? If you look at this attribute C, right? This BMI, we are calculate the BMI with the help of weight. I don't remember exact equation. Weight divided by the height square, right? I think I don't remember exact equation, right? So BMI we are calculating with the help of weight kilograms, height in meters, right? So by using these two units, here height into height, right? Height multiple by height, right? So this is the equation, right? It is this in meter, this is in meter, right? Now, right, attribute redundancy means, right? If you have a, let's say, just imagine you have altogether 100 attributes, right? So sometimes, right, some attributes are derived from one or two attributes. If you look at this BMI is derived from your weight and your height, right? So it means the BMI duplicating the features of your height and weight, right? So it means BMI attribute is highly correlated with your weight and your height, right? So at that time, what will happen if you apply the correlation analysis, right? From the correlation map, you can find out the relationship between the attribute, right? So if you look at the correlation between the attribute C with A and B, they are highly correlated, right? So at that time, rather than you are using these A and B, directly you are using this attribute C, right? So it means it is similar to redundancy, right? Not exact redundant, right? But some point, right? The attribute A and B highly related, or they are uh, influenced by these A and B, the attribute C will change, right? So tuple redundancy means you can apply the normalization. Up to now, you can remember if you have a duplicate values in the records, you can apply the normalization techniques before you can uh, deal with your data or train the model. If similarly, if you have attribute redundancy means you can apply the correlation analysis, right? So correlation analysis, they have some equation, right? So you don't need to worry about those equation. If you need more knowledge, you can learn. That is a statistical thing, right? Correlation is a statistics part, right? If you are if you have sound knowledge on statistics, you can understand what is that correlation analysis and how they will find out the relation between attribute, right? Just as a IT guy, maybe you don't need to worry about that one, right? So before you integrate, you need to think about the data inconsistency. Similarly, you need to think about the redundancy. We have two types of redundancies. Triple redundancy, by applying normalization, we can sort it out, the triple redundancy problem. Attribute redundancy problem, we can sort it out with the help of correlation analysis, right? So correlation analysis means it will show you a heat map, how the attributes are correlated each others, right? Let's say if you have 100 attributes, your correlation map is a 100 into 100, right? 10,000 boxes, right? Let's say I think this is happened this way, right? If you have a three attribute, if you have a three attributes, here altogether 9 boxes, right? So this is attribute one, A1, A2, A3. Here A1, A2, A3. Likewise, you are getting one correlation map, right? So here highly correlated things, the diagonal elements are highly correlated, right? So others are certain number of values. So from these certain number of values, we will find out highly correlated attributes and we will omit some other attributes, right? So attribute redundancy, to find out the attribute redundancy, the duplication of attributes, we apply the correlation analysis. So the correlation analysis means we will find out one attribute varies, one attribute value vary from those another, right? So what is the level one attribute vary from another attribute, that is we can call correlation analysis. Right? By applying correlation analysis, we can easily find out attribute redundancy, right? So it means if you look at the weight, height, and the BMI, so the attribute BMI highly correlated with weight and height, right? So it means it's close to 1, maybe 0.9 or 0.8, right? Likewise, we can remove the redundant attribute, right? So you don't need to worry about, just think about there are two types of redundancies in your database or data set, tuple redundancy and attribute redundancy. Tuple redundancy, we already know normalization techniques to remove the record or tuple redundancies. Attribute redundancies, we are using the correlation analysis, right? So correlation means you will check mathematically, we can calculate how variables are related to each others, right? If you have 100 attributes, we will find out the relations, how they are related to each others among the 100 attributes. Based on that, we can remove the attribute redundancy. Right? Attribute redundancy means the similar attribute, right? Maybe one attribute, we apply some techniques or some calculations, we are converting to some other forms, right? But both are same, right? So those type of things we can remove, right? If you have more number of attributes, what will happen? You need more computational power, right? That is a reality. If you have a more number of attributes at the time you are training the model, you need more computational power. That is the thing, right? So the simple thing, if you have an image, right? If you have an image with 100 pixels into 100 pixels, another one have 1,000 pixels into 1,000 pixels image, right? So if you have a data set based on the 100 into 100 pixels, here you have 10,000 features, 10,000 attributes you need to uh, train the model, right? Here 1,000 into 1,000 in the sense these number of features you have, right? So what I am telling here, you have more number of features. Attribute means you need more computational resources, right? Let's say if you have a 10, if you have a 500 images with 100 into 100 pixels, similarly, you have 500 images with 1,000 into 1,000 pixels. Which one you need more resources to train the model? This one you need to more resources, right? More computational power required for these. Why? Here you have these number of attributes, right? Here you have only 10,000 attributes, right? So the problem here, if you have use the same attribute, actually attribute redundancy means you are using the same attribute with more numbers, right? So it means you need to consume more computational power, right? So it is a big challenge for you, right? That is the same thing. Let's say if you are developing a mobile application or whatever the things, right? You need to think about the memory consumption of that application, right? That's why we apply some garbage collections and uh, cleaning mechanisms, right? Once you complete the process, the memory, it automatically free up, right? So the Java have automatic garbage collection facilities, right? So whatever the application you are developing a mobile application, you need to think about the memory consumption of that application, right? Let's say normally the people are using 4 GB RAM application, right? The mobile handheld devices nowadays maybe 4 GB memories, right? RAM space. Maybe if your application consume 3 GB, that is not a good application, right? For that purposes, normally if you are developing an application, not only the business logic, also you need to think about the other aspects, right? What is the memory consumption, how processing power needed. So based on that, you need to develop the application in efficient way, right? Similarly, if you integrate the data, definitely you need to think about the redundancies of your attribute, right? If you have a more redundant attribute, what will happen? As a result, you have more computational power and resources, right? So it is a big challenge to provide, right? If it's a simple application, no need to worry about that one. But if you have a large application with huge big data, if you have an redundant attribute, definitely it will influence, it will affect the outcomes of your model training. That's why we need to give more priority for remove the attribute redundancy as well, right? So how we can remove the attribute redundancy with the help of correlation analysis, right? Okay. Yeah, the next thing, data reduction, right? First, we will look at data cleaning, then we will look at data integration. Third one, data reduction, right? Reduction means reduce the data. Now tell me, if you reduce the data, what will happen? Tell me. Let's say you have a 10,000 data. If you reduce the data, what will happen? Is it a positive impact or negative impact? What do you mean by that? Data reduction means you can reduce the data size. What will happen? If you reduce the data, what will happen?
Is influence the efficiency of the system.
Yeah, it's correct. What else? You have a big data, right? Or maybe you have a huge amount of data, right? Now, data reduction also one of the pre-processing technique, no? So if you directly look at data reduction, whether it's positively impact or negatively impact on your results.
Positively impact.
How?
We don't have the highest storage spaces. It's just enough to store the less storage space.
Yeah, that is correct. But yeah, maybe we can serve some spaces, right? If you reduce the data, right?
We can fastly process the processing time.
Yeah. Maybe you can increase the computation works, right? It will speed up the processing works. Also, you can serve some spaces, but not. Yeah, your way is correct. But rather than that benefits, you have more drawbacks, right? If you reduce
Negative
the
means, losing some importance data.
yeah, very good.
Oh.
So the normal thing happen if you reduce the data, you can lose some more important features or more important things from the data, right? So then how we can reduce the data? Tell me. Normally, if you look at from outside, data reduction, definitely it will negatively impact your results. But we need to do that one. Then how we can reduce the data?
Avoid the duplication of data.
Sorry? Avoid the duplication.
Avoid the duplication of data. Rather than deleting the original data, we can avoid the duplication data.
Yeah, that is also correct, right? Yeah, definitely we need to avoid the duplication, right? Normalization, right? That is correct. My question is, right? Just think about maybe you have a subject called statistic, right? So for that statistic, you learn something called sampling, right? Am I correct? Population and sampling, right? So if you do something statistical thing, you have a population, right? Can you tell me what is the relations between population and sampling? From a population, you take a sample, right? So what are the unique things you need to look at? If you have a population, from that population, you are take a sample, right? So what are the factors you need to consider while you take a sample? Tell me. All the things I am practically talking with some examples, right? The reason, rather than I will explain the things a theoretical manner, if I explain with some example, you can memorize the things easily, right? Your lifetime, you don't remember those things, right? That's why I explain with some examples, right? So you know the population, right? So if you do some statistical analysis or something, let's say, just imagine, right? You are doing a research or you are doing something, your population is undergraduate students of Faculty of Technology, right? Okay, that is your topic. You are doing some statistical analysis. For that statistical analysis, you are consider the population undergraduate students of Faculty of Technology, Southeastern University of Sri Lanka, right? Now, what is the population? Maybe we have 4 batches, right? For each batch, approximately 200 students, right? So BST and ICT, right? So altogether, right, undergraduates means maybe 4 or 5 batches. For each batch 200, your population is 1,000 students, right? Your population is 1,000 students, right? So why we are using the sampling? Tell me why we need to use sample rather than using population. Hmm? These are the very, very basic things. You don't need to know about data mining knowledge. Even if you have a sixth, then you can answer my question, right? Already you know those things in your grade, first year, right? Maybe you know those things in your O level or A level statistic. You learn the basics, right? So in this example, your population is 1,000 students, right? But we are taking only 100 students, right? This is the sample, right? Now, rather than I am using the entire population, why I am using the sample? Tell me.
We can get the information that we want easily.
Yeah, easily. Yeah, very good. So if you consider all the population, it takes huge time, right? Let's say you are prepare a questionnaire, right? Or maybe you can prepare some set of questions. Your target is you need to do an interview, right? You are preparing a questionnaire, set of questions, right, for an interview, for an interview. So that is your topic, right? To do your research, you need to prepare set of 25 questions, right? You need to ask these 25 questions as an interview, right? Just think about, so, okay, 25 question, you need 15 minutes, right? You need to spend 15 minutes. What will happen if you apply for the population? 1,000 into 15 minutes, how long? This number of minutes, right? If I divide it by 60, then how long it will take? Cut this one and this one. 250 hours, right? So you need to spend 250 hours, right? Around 10 days, full day, 10 days, right? So what will happen if you apply the population for data collection? You need to spend more time, right? Also, you need to spend more resources, maybe your human resources, or maybe you need to travel. So if you apply for the entire population, it's a very difficult task as well as it is a very time consuming task. So that's why we are not considering the entire population. We are picking some samples, right, to carry out your interview, right? So if you have 100 students, it will take this number of minutes, right? So if divided by 60, sorry, this is 15 minutes, right? So for each 15 minutes, then 150 divided by 6, 25 hours, right? 250 hours, only you need to spend 25 hours, right? So rather than you are using the entire population, if you are using a sample, right, you can avoid uh, more time consuming. Also, you need to avoid some more resource consumptions, right? That is one way. Rather than we are using population, you are using sample, right? Another important thing here, you have a big challenge how you are picking your sample. That is important, right? Now tell me, for the same research, someone collecting all the 100 students from ICT department of ICT. Is it correct? So already I told you, if you do a research for the entire population, it takes huge time, right? Also, you need more resources. To overcome this issue, we are using some sampling techniques, right? We are picking a sample, right? At the time, you have a big challenge, how you are selecting your sample, right? Maybe you can collect the samples in different way, right? In this example question, my research is maybe I'm analyzing something, Faculty of Technology students of faculty, undergraduate students of Faculty of Technology, Southeastern University of Sri Lanka, right? Now at the time, one person collect a sample right? 100 students, all the 100 students from Department of ICT. Another person collecting all the 100 students, it means the sample, all the students are from Department of BST. Another student collect 50 samples from ICT, 50 students from BST. Okay, now tell me, what do you think about these three samples? Which one is acceptable one? Tell me.
Last one, sir.
Last one is acceptable. Why? If I pick the first sample, it's a biased one, right? So just imagine, I am doing a statistical analysis, their technology knowledge or their IT knowledge. My research is undergraduate students of Faculty of Technology, Southeastern University, the awareness of online banking applications. Or maybe I'm thinking about the awareness of cloud computing or whatever. I need to analyze, I need to get some decisions or statistical analysis of their specific IT knowledge, right? So at that time, right, my research topic says undergraduate students of Faculty of Technology, right, not Department of ICT, right? So if I take this sample, this is a biased one, right? This is a biased sample, right? Because all the students have IT background, right? If I do some questionnaire or interview, definitely I'm getting whatever the uh, positive outcomes or positive results, right? Similarly, if you think about the BST students, maybe they have lack of IT knowledge, right? So if I do a analytical thing, it is also a biased thing because of all the student samples are picked from the BST, right? To overcome these, I need to pick equal weight for both departments, right? So what I'm telling here, if I pick the sample, right, your sample, if you're selecting a sample, your sample represent the entire population, right? That is important, right? Your population is first year, second year, third year, fourth year, undergraduate students, right? Both department ICT and BST, right? So now what will happen? So if you pick a sample, your sample influence, your sample represent the entire population, right? So here, if you look at this one, the first sample, it will only represent the ICT population. This is represent only the BST population. So this one only represent the both uh, populations. BST is there, ICT is there. Now tell me, okay, now we have 50 ICT, 50 BST, right? Now, among these, right, again, you need to think about, right? If your population is undergraduate students, Faculty of Technology, Southeastern University means you have 4 batches, right? First year, second year, third year, fourth year. Altogether, we can say undergraduates, right? So among these 50 ICT students, you need to provide equal weights, maybe 12 students for first year, 12 students for second year. Likewise, you need to provide equal, not exactly, maybe equal, right? 12 for third year, 12 students for third year, maybe 13, or maybe for maybe this one and this one, 13 students for fourth year, right? This is another important thing. Similarly, among the 50 BST students, 12 students for the first year, 12 students for the second year. Likewise, you need to provide. So then only your sample represent the entire population, right? Now what will happen? All the 50 students you are taking from the final year, fourth year, or maybe all the 50 BST students, 25 from the third year, 25 from the fourth year. Is it a balanced sample? No, right? So what I'm telling here, if you pick a sample, that sample represent the entire population, right? So entire population means this one, 12 students from the first year, 12 students from the second year. It means while you are getting this type of sample, what will happen? Your sample represent the entire population. The same concept we can apply in the data reduction, right? While you, even if you reduce the data, the important thing, the content or the meaning of the data will not change. That is important, right? So definitely we need to reduce the data, right? So at that time, we cannot randomly reduce the data. If you randomly reduce, what will happen? It will affect the meaningfulness of your data. So you need to be careful, right? While you reduce the data, the important thing you need to remember that will not affect the representation of your entire data set. It means the meaning of the data will not change. That way you need to reduce the data, right? So did you get my point? So I will explain with the sampling, right? So if you have a population, once you pick the sample, definitely that sample represent the entire population, right? The same concept we can apply while we are reduce data reduction. While you reduce the data without change the meaning of the entire data, you can reduce, right? That is more important thing you need to think about. So normally what will happen? Normally, just based on my experience, I'm telling, right? Some of the students last year also, they are collecting some data from the Kaggle or some UCI repositories, right? There are so many online repositories are there for data sources. Just they are collecting the data from that repository, right? That repository have millions of records. Maybe if you have, let's say, diabetic patients, right? They have 10,000 patient records, right? So, but you need only 1,000 records. You are not thinking about anything. Just you are keep first 1,000 data records, first 1,000 tuples. Just you can delete the remaining tuples. That is not the correct way, right, to reduce the number of data, right? Sometimes what will happen? Let's say in their online data source, right? Let's say they in the online data source, 1,000, maybe 10,000 samples are there. First 5,000 samples, first 5,000 samples for male, another 5,000 samples for female, right? Now, one student, without considering anything, just he can delete these tuples, right? He will take first 1,000 tuples, right? Now, at the time, what will happen? His population, that's the population of 1,000 students or 1,000 patients only for male diabetic patients, right? It is a biased thing, right? It is not the proper way. Even if you reduce the data, first of all, you need to analyze your data. Before you reduce the number of tuples, first thing, you need to analyze the records, right? Then only you can uh, reduce the number of data without affecting the meaningfulness of the data, right? So yeah, if you read this point, you can understand, right? So what they are telling, so data reduction is a third data pre-processing technique. Right here, the aim, the objective of this data reduction to obtain a reduced representation of the data set. That is, it means a sample, right? You need to reduce the data set, right? Smaller in volume. The size is small, but the important thing closely maintains the integrity of the original data, right? Without changing the integrity. It means the meaningfulness of your data without changing, right? Very closely maintain the integrity of the original data. Even if you have a 10,000 data records, then if you convert into 1,000 records, definitely the meaning of this one and this one equal. Then only we can reduce. Otherwise, we can't reduce the data. For that type of reduction, we have something called PCA, Principal Component Analysis. I already explained, I think. So just you can learn how the principal component analysis works, right? So this is one technique to reduce the number of attributes, right? Not only records, by using PCA, we can reduce the number of number of attributes, right? Now, at attribute reduction, we can use principal component analysis. If you have 50 attributes, Even you can convert into 5 or 10 attributes without changing the meaning of your data. That is important, right? So previously we discussed data cleaning, then we discuss data integration. Now we are discussing about data reduction. The important thing while you are data integrity, we discuss two things, right? Inconsistency removal and redundancy removal. Attribute redundancy with the help of correlation. The tuple redundancy, we apply the normalization techniques. Now we are discussing the data redundancy, right? So the important thing here you need to remember, if you reduce the data without, definitely you need to think about without changing the meanings fullness of your data. Without changing the integrity of your original data, you need to reduce the data. Now we will look at what are the different reduction strategies. So data reduction strategy. There are three different types of data reduction strategies. The first one, dimensionality reduction. Second one, numericity reduction. Third one, data compression, right? Yeah, I'll speed up. I need to complete by today, the slides, right? Okay, now we will look at three different types of data reduction strategies, right? How we can dimensionally reduce, how we can numericity reduce, and data compressions, right? We'll look at one by one. If you look at the dimensionality reduction, what do you mean by dimension, right? I already explained dimension in data warehousing, right? While you are looking at the synonyms of attributes, I will explain dimension. Right? What do you mean by dimension? Dimension is similar term for attribute, right? If you have a data warehouse, normally we are using dimensions, right? Data cube is there. For data cube, dimension means that is also an attribute, right? That's a variable, right? So dimensionality reduction means you can reduce the number of attributes, variables, right? So data reduction means just think about you have a data, right? So data means that's think about an Excel sheet, right? They have columns and rows, right? So dimensionality reduction means you can reduce the number of attributes. That is, we can call dimensionality reduction, right? So let's say normally we need this, let's say this is a table, right? Let's say you have a maybe 100 attributes, right? So then if we cannot use all the 100 attributes, maybe we have more computing resources, or maybe some attributes are not highly correlated with each others. So based on these, we need to pick some few attributes, right? So for that purpose, we are using this dimensionality reduction, right? Dimensional reduction means we can reduce the number of attributes, right? For that reduction, attribute dimensional reduction means you can reduce the attributes, right? So the attribute reduction, maybe we can use two techniques, wavelet form transformation or principal component analysis, right? So normally we are not discussing these two things, right? These are machine learning part, right? So if you need to know those things for your undergraduate research, maybe you can separately learn these two things, how the PCA works, principal component analysis works to reduce the dimensionality, how to reduce the dimension by PCA. They have some codings, right? They have some inbuilt libraries in Python. Just call the libraries and you can easily apply the PCA for your data set. So dimensional reduction in the sense you can reduce the number of attributes, right? The important thing is principal component analysis reduce the dimensions, attributes without changing the internal meaning of your data. Another way to reduce the attributes, right? Let's say you have 100 attributes. From this 100 attribute, you are selecting a subset of attribute. You have selecting a specific subset of attributes for your research purpose. These are the two ways you can reduce, right? Let's say you have 100 attributes. Maybe based on some scenarios, you are selecting the subset of 5 or 6 attributes, right? That is one way. So maybe to reduce the dimensionality, dimensionality reduction is one way of data reduction. So dimensional reduction, we can use wavelet transformation or principal component analysis or attribute subset selection. These are the techniques we can use for reduce the dimensionality. Okay, the next one, numericity reduction. Yeah. So numericity reduction means we can replace the original data value by alternative or smaller forms of data representation. How we can say this? Okay, I will explain with an example, right? So previous case, dimensional reduction in the sense, right? You can reduce the data attributes, right? So if you have 100 attributes, you are converting to 25 attributes without changing the internal meaning, right? Whatever the type of reduction, you need to think about without changing the internal meaning, right? Okay, now just look at here. You have a table called, right? Okay, just think about the bank table, bank database table or something, right here. Yeah, they have attribute for let's say this is a customer ID. This is a customer ID, account type, right? What is the interest rate? Interest rate, right? The duration, the time, the base amount, right? So these are basic table, right? You have a customer ID, 001, account type, maybe serving account, his interest rate, 15 percentage, right? Duration he put for 5 years, right? The base amount, the total amount he deposit for his account, maybe 10 million, right? Okay, numericity reduction in the sense, this is a simple example I will tell you, right? So here, if you look at here, you have three attributes, right? Interest rate, duration, and base amount, right? Rather than we are using these three attribute, right? So here you have a customer ID, here is a account type, here maybe you have a calculation, right? Let's say maybe we'll calculate the maybe something x, that x based on this interest rate multiple by duration time multiple by base amount or something. Maybe there are some equation, right? Rather than you are using these three attributes, you are using one new attribute or new value by using these three values, maybe that is x, right? So in this x, you can represent, this x represent all the three attributes, interest rate, duration, and the base amount, right? So that is one way, that is we can call numericity reduction, right? So we are converting some attributes by using some equation, right? Maybe for the, maybe you have, if it is an interest calculation, maybe you can, rather than you are using these three values, maybe you can change this one as an interest, right? So they have some interest is equal to maybe their interest rate multiple by time in years and multiple by the base amount or something. So then rather than I using these three, directly I can use their interest, right? So that is we can call numericity reduction. Rather than we are using more number of attributes, right? So by using these, but now what will happen by using these values, right? Here, customer ID 001, that is a serving account. Here, 15% is a one value, 5 years one value, 10 million is a one value. So rather than this one, what you can do, 15%, 5 years multiple by 10 million. Maybe you can cut this one. You are getting some interest value. So maybe you can replace 75,000 or something. This is a interest rate. Rather than we are using these three values, you are putting these new value. But the important thing, that value fully influenced by these three parameters. That is important, right? So that is numericity reduction, right? The third one, data compression, right? So compression, I think you know, right? Maybe you have familiar with compress the files, right? What do you mean by compress the files?
Reducing the size of the file.
Yeah. Here also, what will happen, compress the file in the sense, right? Just you can reduce the file size without changing the meaning. Just imagine you have a uh, 50 images, right? So now you are compress the image. Now because of the compression, the size of the file will reduce, but there is no any changes in your image. Once you decompress, extract the compressed file, what will happen? You are getting the same image, right? So it means without changing the meaning, right? Even if you compress the data, just you can reduce the size of the data, right? Your original data is reconstructed without losing the information, right? That is important. So whatever the data reduction techniques, the important thing, you cannot lose the data, right? If you lose the data, that is not a data reduction, right? So without changing the meaning, we can reduce the data. So there are three ways. Dimensional reduction means attribute reduction. Numericity reduction means we are changing the values without affecting the meaning. The data compression means reduce the size. So we can reduce the or compress the data without changing the meaning, right? These are the three ways. The last one, transformation, right? Data transformation. Transformation means you transform your data into a different form, right? Now tell me why we need to transform. That is important. Whatever the steps, they have some importance, right? If you understand the importance, then only you can easily understand, right? The last one in the data pre-processing, data transformation. So you are transforming the data from one form to another format. Why we need to transform? Tell me. What is the purpose of transforming the data?
To adapt the particular data with another.
Yeah, maybe. So the transformation means, let's say you have one attribute, right? So that attribute value in a particular scale, right? You are converting that scale into another scale, right? That is transformation, right? Let's say, yeah, think about, okay, you after we are correcting your exam papers, we have marks, right? In your exam paper, we are putting a marks out of 100, right? Then while we submit to the examination branch, we are transforming your marks into grades, right? A, B, C. Likewise, we are transforming. So that is one example of transformation, right? Numeric to letters, grades, we are transforming, right? So similarly, data transformation have some requirements. Why we need to transform the data? One important thing is there. That is, I need to expect it as an answer, right? Why we need to transform the data? Today I explained those things as well. Tell me. Tell me. Why we need to transform the data?
To reduce the redundancy.
That one.
So say according to our system, we want to change our data set into the appropriate format that is suitable for our application.
Yeah, maybe, yeah, it's too close, yeah. So the important thing, right? The ultimate answer is to reduce the computational resources. That is the one thing we need to reduce the, that is one thing we are transforming the data, right? Okay, I will explain. Maybe you have, maybe I think you don't know up to now, right? Once you learn, I told you, right, image processing and computer vision, right? So if you learn the image processing techniques, right, normally if you are doing the image data set related research, right, normally, let's say if you have an image, right, just for the research purposes, you are collecting some sample image data sets, right? So at that image, they have more information, right? Let's say, it means you are collecting the image 1200 into 1920 pixels. This is the size of the image you are taking, right? Let's say you are taking 100 samples or 100 disease leaves or something, right? So here, if you look at the size of the data, let's say maybe we will look at 1000, maybe we will consider the images are the pixels value 1000 pixels into 1000 pixels, right? So this is the size of the images, right? So this is a pixel values for your image, right? Here we are transform this image into 250 pixels into 250 pixels, right? This is a normal transformation, right? Why we are transform? Here we have more number of features, right? Without affecting the meaning, we are reduce the size, right? Maybe you can try this one in the paint tool, right? So if you have an image, you can open in the paint tool, right? So maybe if you have a big image, they have large number of pixels values. Pixels values means that's the information, right? The information about your image, right? So there are something called resize the image. Then you can select what is the pixels value you want, right? So that is one way. It means without affecting the image, without changing the image, right? You are reduce the number of information, right? This advanced machine learning thing, right? If I explain here, you can understand, right? So if anyone planning to do a research image related or video related things with machine learning, you can learn those things, advanced machine learning, right? And image processing, then you can learn the depth level things, right? The data transformation in the sense, now just tell me, let's say you have one at, yeah, the easiest thing, right? You have a table, right? In this table, right, you have different attributes, right? One attribute is maybe his salary attribute, right? Maybe one, his salary is 4,55,000, 50,525, right? His age, maybe his experience. These are the attribute, right? Now, if you look at here, the salary values are high values. Maybe someone take 10 lakhs as a salary, right? His age is 45. Maybe he have 25 years of experience, right? The for like 50,000, maybe 5 years experience, right? Likewise, you have some data, right? So if you look at these salary attribute, maybe there are ranges, maybe 50,000 to maybe 15, okay, 15 lakhs, right? Maybe this is the value for the salary. Similarly, if you look at the age, maybe ages are 20 to 60 or something. That is a range. Similarly, for the experience, maybe 1 year or 0 year experience to maybe 35 or 40 years. These are the range for the values, right? So if you train or if you feed these data into a machine learning algorithms or whatever the algorithms, right, what they are doing, they will computationally, the mathematical model, the machine learning model in the sense, they will find out the relations between the attribute in the mathematical way, right? Maybe it means they are doing some calculation internally between these attributes and they will learn something, right? Now what will happen if you have look at these ranges of the attribute, if the range values are increased, what will happen? Let's say sometimes what will happen for this salary attribute, they will find out some relations with their experience, right? For that purposes, maybe they will calculate the multiplication of salary and experience, or they will in the internally they will learn something with the salary and the experience, right? So now what will happen if you are using different range attribute, it takes more computing resources for the calculation parts. Or also, if you are using different range for different attributes, you are not getting the expected outcomes from the data. For that purposes, we are transform the data, right? So the purpose of transforming the data, reduce the computational works. That is a major thing. Another importance for transforming the data. Once you transform the data into same range, you are getting more benefit, right? More symmetrically distributed data sets, right? Rather than if you are using in the normal way, right? Maybe let's just think about if you are planning to plot this data in a 2D or 3D dentagram. Now what will happen? Hmm? The range for the salary is a huge value, right? Maybe let's say if it is a salary attribute, maybe this is the places your salary comes, right? But if you look at the experience, maybe this is experience, maybe experience maximum 0 to 35 years, right? So within this range, your graph comes, right? So it means you are not getting a more generalized images, right? To overcome these type of challenges, we apply the data transformation techniques, right? Okay, now we will look at, there are different data transformation techniques, right? We will look at one by one, right? Up to now, we discussed some of the data transformation techniques, but we don't know whether it's a data transformation technique or not, right? Now here, we will look at all the available data transformation techniques, right? The first one is a smoothing, right? Do you remember the binning techniques? Hmm? So outlier removal, we discussed something called binning techniques, right? Smoothing, right? So the noisy data removal, right? We are split into n number of bin. That is one way of transforming the data. Actual data, if you have abnormal values, right? Maybe we can use interquartile range, Q1 minus 1.5 times into interquartile range, or less than 1 Q3 plus 1.5 times into interquartile range. We have some equation. Other one is smoothing techniques by using the bins, right? Binning, right? So that is one way of transforming. That is we can call data transforming, right? We are transform the data into different ranges, right? Another data transformation technique, attribute construction, right? The previous slide I explained you, right? Here we are creating new attributes from the existing attributes, right? That is one thing we can call. Let's say this is weight, this is height. So maybe this is the patient ID. So if you have these three, maybe from this one we are creating patient ID and BMI, right? So from these three attributes, we are creating only one attribute. From these two attributes, we are creating one attribute, that is BMI, right? So that is a new attribute creation, right? So attribute construction also we can call, we are transforming the data. The third one is aggregation. Aggregation means summary of the things, right? So let's say you're running a food city, or maybe you're running a restaurant, right? So for the restaurant, you have different number of transactions, the food orders coming each day, right? So rather than if you are and record all the day-to-day transaction, maybe you are get the summary of weekly transaction or the monthly transaction, right? So it means you're converting your data into a different form, right? In your business database, you have day-to-day transaction. What is the income every day? What is the profit every day? Rather than we are using that one, we are converting or we are getting the average summary of the weekly transaction, right? That is one way we are transform the data into different forms, right? Aggregation means where summary operations are applied to the data, right? So rather than you are using the daily sales data, maybe you are do the calculations or computations and you can find out the monthly or weekly incomes or total monthly incomes. Likewise, we are apply some transformation. The fourth one, the normalization techniques, right? This is not the database normalization. This is different normalization, right? So normalization means we are converting the variable range, whatever the range, to a specific range, right? That is normalization. Let's say in the previous example, I told you the salary attributes are 50,000 to maybe, just imagine, 75,000, right? If you have a, this is the range of the salary, then we are converting this salary into maybe 0 to 1 range. This is one way. Maybe sometimes maybe you can convert into 0 to 100 range. So this is called normalization, right? So this is not the database normalization. This is something different, right? Normalization means even if you have whatever the range for your variable, you are converting your data into different form. That is we can call normalization, right? Now we will look at this normalization you can learn right in the practical session, right? So how this equation works, right? So the next, this one, I will explain this one, right? Yeah, this normalization, right? Just think about this is your data set, right? So, we will look at with this normalization, max min normalization. Maybe here also for this one also, for the conversion from 0 to 1 or whatever the range, we have different techniques, right? Here only we are look at the min max normalization and z-score normalization, right? Likewise, decimal scaling. There are so many things are there, right? Especially I will explain this one, right? I think this one is a z-score, right? Maybe after your A level, you are getting something called z-score, right? Uh, yeah, that is one way of normalization, right? Normalization means whatever your value, they are converting the value into a particular range. That is normalization, right? So now we will look at min-max normalization, right? For the minimum maximum normalization, just imagine you have a set of data, right? Just imagine you have, these are the data records you have. How many data points? 1, 2, 3, 4, 5, 6. You have 6 data points are there, right? You have 6 data points are there. Now tell me what is the range of these 6 data points? What is the range? If you have any set of data, we can easily find out the range, right? So range means minimum to maximum value. That is the range. So what is the minimum value? 10. 10 is the minimum value. Maximum value 110, right? So this is the range, right? Now we can transform this 10 to 100 range into 0 to 1 range, right? So maybe we can define what is the range I need to transform, right? It's up to my requirements, right? Let's think about this example. I will convert the range into 0 to 1, right? I will explain, right? The reason why we are transform the data, right? If you directly apply the data, if you without any transformation, if you directly use the data, right? Definitely sometimes you need more computations, right? The simple way, just think about, let's say, uh, just imagine, right? You have some values, right? Let's say you have, you have uh, one attribute, right? The attribute values are 125,750, right? This one multiple by 6 years of experience, right? So to do the calculation or to get the multiplication of these two values, you need more computational resources. Maybe just think about after you get the multiplication, you're getting a big number, right? So you're getting a maybe around 750,000 or something, you are getting a big value, right? To store the value, at least you need some more storage, right? But if you convert this value into between 0 to 1 range, maybe if you convert this value into 0 to 1 range, maybe this value comes as a maybe 0.7512 likewise. Then if you, maybe you're getting some value, right? Then if you get the multiplication, you're getting a small number. Maybe compare with this one, you need a small space is enough, right? Once you transform, not only that one, right? Once you transform the data, right? The important thing, we are not dealing with only one attribute, right? We have more number of attribute, right? So once you transform all the attribute into the same format or same range, it's easy for us to do the calculation, right? They have some uniqueness. They have some smart things in your data once you apply the transformation technique, rather than you are dealing with without doing any transformation, right? So the normal thing, if you have dealing with the numeric data, you need to apply the transformation technique for all the attributes, right? Then you are getting a more unique and some how to say, some neat results, right? Some neatness in your data, right? That is one way. Maybe normally we apply this normalization technique with image data sets, right? So I think you know the image pixels, right? So pixels are from 0 to 255. That is the color range. If it is a color image, there are three RGB, red, green, blue. There are three values, right? So all for the red, you have 0 to 255. For the green also, you have to 0 to 255. Blue also you have 0 to 255, right? So depending on this value, your image have different colors, right? So if you are capturing an image, means each dot is a one information, right? So if it's a color image, in each dot you have these three values, right? For the red, green, blue, you have some specific values, right? So rather than you are using these 0 to 250 values, we apply the normalization and we are converting this value from 0 to 1 range, right? So the meaning, the reason why we are converting the 0 to 1 range, to reduce the computational resource requirements. That is the ultimate thing. To reduce the computational works or to reduce the computing resource what we need, we are normally apply the transformation techniques, right? Clear now? The ultimate thing, to reduce the computing resources what we need, right? Now we will look at the normalization, right? In the normalization, first technique, min-max normalization. Min-max normalization means you are considering the minimum value, also you are considering the maximum value. By using these two values, you can calculate the normalization. That is, we can call min-max normalization, right? To calculate the min-max normalization, right? In the previously, your variable range from 10 to 110, right? This is your range. The values, all the six values are between 10 to 100, 10 to 110, right? 10 to 110. Now I need to convert these values, these six values between 0 to 1. That is the min-max normalization. If I ask you to apply the min-max normalization, maybe whatever the range you have, you need to convert into the 0 to 1 range. Not only 0 to 1 range, whatever, it's up to you. Maybe you are converting into 0 to 10, or maybe you are converting into 1 to 2. It's up to you. You are the one decide what range I need, right? To find out these, we have some equation, right? By using this equation, you can easily convert the values, whatever you want, right? The equation says, let's say VI means that is a data point, right? Let's say now your first data point is 10, right? Now you need to 10, you have a data point 10. This data point you need to convert into 0 to 1 range, right? So your new maximum value is 1. The new maximum range is 1. New minimum range is 0, right? Plus new minimum range 0, right? The equation says, first you need to find out. So the VI is equal to, equation says the first VI value. So VI is 10 minus minimum value. So what is the minimum value? Minimum value means in your range, the minimum value. So 10. So this is minimum value in the actual range minimum value, 10 minus 10 divided by maximum. Maximum is 110. 110, sorry, 110 minus minimum value 10 into new maximum value. New maximum value. The new maximum value is 1. 1 minus new minimum value 0 plus new minimum value 0, right? Now, if you calculate Vi is equal to 10 minus 10, 0. 0 divided by 100, 0. 0 multiplied by 1, 0 plus 0. So now the Vi value is equal to 0. Now, what actually what will happen here, right? In your data set, 10, now we are converting this 10 into 0, right? Now we can apply the same thing for 15. So now Vi is equal to 15 minus, tell me what is the minimum value? So this minimum value means in your range, the range minimum value is 10 divided by maximum 110 minus minimum 10. Then multiple by new maximum. New maximum is equal to 1. This value, new maximum is 1 minus new minimum is equal to 0 plus then new minimum is equal to 0. Right now, if you calculate this one, what is the answer? 15 minus 10, 5 divided by 100. 1 minus 0, 1. So then 1. So it means 0 we can omit, right? So 5 divided by 100. So now the 15, you are converting this 15 into 0.05, right? Similarly, for this one, you can calculate. So if you calculate for this one, you are getting the answer. You are getting the answer as a 0.15. Similarly, for if you calculate for this one, you are getting the answer 0.35. Similarly, for this one, you are getting the value for 0.70. Similarly, if you calculate for this one, what is that? 1.0, right? So that is the range. We are converting all the values, different range to 0 to 1 range, right? Not only 0 to 1 range, as a homework, right? So, okay, as a homework, just try this question, right? As a homework, right? Okay. Okay, in this question, I'm giving you, this is your data set, right? For all the 6 data points, now you are converting into 0 to 1 range, right? Now, as a homework, you can do, you need to convert the range 0 to 10, right? As a homework, try this one, right? So previously your range, we are practice now with 0 to 1. Now I'm asking you to convert into 0 to 10 range, right? Try this as a homework, right? So that is min-max normalization. The next one is a Z-score normalization, right? Maybe after your A levels, once you release the results, right? You have a such scores, right? Maybe 1.5, 1.6, likewise, right? So that is one way of normalization, right? So the normalization here, the normalization, the equation says, let's say Vi is your marks, right? Let's say that is your Z score. Let's say we need to find out the Z score for engineering technology, right? Just think about, you need to find out the Z score for uh, engineering technology, right? For that Z score, how you can find out the Z score for engineering technology, right? You have a set marks, right? Let's say for 100, maybe you are getting 75 marks, right? So the A bar means for that engineering technology subject, they have some mean marks, right? Mean, the average marks, right? Average means how many students sit for the exams. Then you are getting the sum of all the marks of that engineering technology subjects, then divided by total number of students. Let's say, just imagine the mean marks is 35, right? Divided by sigma A means that is a standard deviation, right? We have some calculations to find out the standard deviation. Standard deviation. From that standard deviation, you are getting some values, right? Let's say the standard deviation value is 2 point, let's say 20 point, maybe 25, right? Just imagine the standard deviation SD is equal to 25. Then if you calculate, then you are getting the set score. 75 minus 35, what is that? 40. 40 divided by 25, then what will happen? 8 divided by 5, then 1.6. Your GPA for that particular engineering technology subject, 1.6. Likewise, you can calculate the GPAs, right? No need to worry about, right? These are some different techniques to transform your data, right? So this that score, you already familiar with this one, right? Similarly, normalization by decimal scaling, right? You don't need to worry about everything. Just you can familiar with this first one, right? Min-max transformation, you can familiar, right? If you want, you can look at other data transformation techniques, right? You need those things, right? Once you do a research, right? So if you do a research, you need different things, right? So at the time, you can learn for your research purposes, right? So here we can't explain everything. We can learn the basics, no? So the next one, the data transformation is discretization, right? So discretization is also one way of transformation. Discretization means sometimes we have, uh, yeah, yeah, we have some values in the ranges, right? Let's say sometimes you have numeric values. Those numeric values we can convert into nominal attribute. That is, we can call discretization, right? Did you get my point? Discretization means, let's say, okay, I will explain with an example, right? Customer ID, right? His age, let's say his salary, right? So customer ID 123, age 35, 45, 26, right? Salary is 150K, 25K, 80K, right? So this is one table, right? So these age and salary are numeric values, right? So discretization means this age attribute you are converting into a nominal attribute. How we are converting this age into nominal attribute? We can define some limit, right? The age 0 to 30, we can say young. 31 to 50, we can say middle age. 51, above 51. Above 51, we can say senior citizens, right? So this is, maybe we can define 0 to 30 is a one range, 31 to this way we can define, right? Now we are converting this table this way, right? So customer ID 123, the age 35, it comes this category, right? So we can define this is a middle age. 45 also middle age. So 26 comes within this range. So we can say young. So likewise, we can convert this numeric attribute into nominal attribute. This is we can call discretization, right? Similarly, maybe you can apply for the salary as well, right? Salary below 50K, we can say basic salary, basic level, right? 50 to 250K average salary, right? Above 250K supreme salary or something. Likewise, you can define some nominal values. Then you are converting each and every record into that value, right? It means discretization means converting the numeric attribute into nominal attribute. We can say that is discretization, right? That is one way of data transformation, right? The last one, concept hierarchy generations, right? So concept hierarchy generation in the sense, I will explain with an example. Okay, this is the concept hierarchy generation, right? Just think about, okay. Yeah. Okay, this is the population of particular district, right? This is the population of a particular district, right? 674,339 families are live in the particular district, right? Now, let's say, okay, just think about these are the employees, right? Just imagine this is an employees in, okay, just think about this an employees in an organization, right? So if I ask you the street address, right? Their living home address, I am getting these number of unique addresses, right? So now some situation, or maybe just think about in the quarantine situation, right? This company, normally the company provide the virtual working environment, right? Just think about, I will explain with the simple example, right? I will explain with the practical example, right? At the time, in the corona situation, I worked in Virtusa, right? So suddenly they lock down the country, right? So the company face an issue, right? For the employees, they can't stop their works, right? So Just think about these are the number of employees in the country working in Virtusa, right? Now, what they need to do, right? They need to deliver their PCs or laptops to their home, right? That is their requirement, right? As a company, they need to deliver each and every one device, laptop or PC for their homes, right? Now, they have a big challenge how we can provide all the 6 lakh employees. That's a big challenge, right? So now they apply some data transformation technique, right? So all the 674,000 employees, they will categorize based on the province, right? Just imagine all the 674,000 employees, they are categorized into 9 provinces. Okay, just think about this one, right? Okay, first they will categorize based on the districts, right? So how many districts we have? 25 districts, right? So all the 674,000 employees, they will categorize into 25 groups, right? So now what will happen if they arrange 25 vehicles? Did you get my point? If they arrange 25 vehicles, right, they will maybe they will book 25 lorries or 25 vehicles, right? So each vehicle for one district. Maybe this is for Jaffna, this is for Batticaloa, this is for Ampara, this is for Kandy, this is for uh, Pothuwil. Likewise, they will allocate one responsible vehicle, then their responsibility is they need to deliver the resources in within that particular district, right? So each vehicle, maybe they are getting around 25 or 1,000 uh, deliveries, right? That is the thing here, the data transformation, right? Rather than you are using all the entire instances, we can split. We are categorize the instances based on different labels. Because of that, we are getting more benefits, right? So once you, let's say, you are planning to do a data analytical things for a Pizza Hut, right? So the Pizza Hut, they have different branches in different districts, right? So if you think about the model for the entire country, right, you need to think about all the branch spots into a one, right? And then that one, if you think about an analytical data analytical thing, provincial wise, right? Then you can split all the transaction. Let's say if you think about the Eastern Province, you have two branches, right? Kalmun, Saintamardu, and as well as Batiglo, right? So you collect the data from two branches and you can do the analytical things. Similarly, if you think about the Colombo, they have more number of branches. All the branches located in Colombo district, they will consider for the analytical thing. Likewise, the conceptual hierarchy generation is one type of data transformation. Because of that, we are getting more accurate or more subject related patterns from the data. That's why we are transforming hierarchical transformation, right? These are all the transformation techniques, right? So why I'm telling here, maybe some situation you can apply these type of techniques to do the data analytical things, right? So that's all about today, right? If you have any questions, you can ask. So up to now, we complete all the pre-processing part.